Hey everybody, today we'll do another video, and today we'll continue with the area of differential equation that is called undetermined coefficients. Undetermined undetermined coefficients. So we will find out the coefficients, right? And then we will. The first step is going to be to find complementary solutions. The second step is going to be undetermined coefficients, right? Find the undetermined coefficients. And then the third step is going to be put it together. And when we do find that the undetermined coefficient, that is called a particular solution, right? So basically, we normally what we use is we use some type of function y of t is equal to some type of constant x squared plus bx plus c, right? And those a, b, and c are the one that we're trying to find, right? So those are the undetermined coefficients. Now, so like I say, the undetermined coefficient will give us what is called a particular solution, and the idea is that y general is equal to y complementary plus y plus yp, right? So and this is going to be in the form of this will give us this, and then this one we will use the type of making the homogeneous differential equations. And basically what undetermined coefficient help us to solve differential equations when there is no homogeneous type of differential equation. Okay? So let's say, for example, if I have a function that's called, y prime plus y y double prime plus y prime plus y, whatever, or 10y, whatever, 10y is equal to 0. It's a homogeneous differential equations already. So I don't have to use the undetermined coefficient. But if I have something over here that is not equal to 0, that this differential equation, this derivative, this second derivative, and then second derivative plus the first derivative, plus some type of function of y that is not equal to 0, then I have to, this one right here can be like, maybe sine of x, right? Maybe plus, cosine of x, whatever, right? But if this is in this form, then this is not a homogeneous differential equations. It's not at homogeneous, right? And then it's not a homogeneous differential equation, so therefore we cannot use the straight. We have to use undetermined coefficient method, right? So basically, that's what the whole point of using undetermined coefficients, right? So now let me do an example real quick, and then actually a problem. It's not an example; it's a problem from this book. So as we worked some problems out, we worked number 3, and then we'll do number 5. These problems are not really difficult. It's just a lot of algebra that gets involved. So we need to play with the algebra. So basically, number 3 said that y double prime plus or minus 10y prime plus plus 25y equal equal 30 x plus 3, right? Now, but you know that this is not a homogeneous differential equation. We can actually see it right away because this side right here is not zero, right? So now, what do we do? Okay. Well, we will use the method of factoring or factoring. Also, we can use what is called auxiliary, auxil, auxiliary equation to find whatever is in this side, right? Whatever is in this side, right? So we can use factoring or the auxiliary equation to find whatever is in the left side. Okay, so how do we do that? Well, these are the derivatives, right? So even though if I do the derivative over here, it's not gonna help you, not gonna help out much, right? Because it's going to be dy dx, dy dx squared, right? Over, and then this is going to be dy dx, and then it's going to be equal to this, which is going to be kind of difficult to manage. What we do, what we do right here is some books use D, some books use like to use R, right? Because we find the roots anyway, right? I think R makes sense. So whenever we see y is y double prime, we put y squared, right? And then because it's a second order differential equation, so we do a second order of differential equation, right? So we have an R. Then right here we put minus 10 R to the one power, right? Because it's only y prime, and then plus 25, right? We don't bother in writing the y because I know that y is going to be equal to some things on here, right? But right now we don't know exactly what it is. So what I can do is but this is ax squared, this is plus bx, this is a plus c right here. So that 25 keep that can kind of give me the plus c business going on. So now, so now with that being said, this is like a quadratic function, right? Even though we pull it out from the differential equation, it's a quadratic type of function. What we can do right now is try to factor, right? So how can I factor this? I can say r, right? And then right here, notice that I have a negative, right? So what can I do to add negative 10, right? Can I add to negative 5? Yes. So I put negative 5 here just to try it out. Remember, we're just testing stuff out, right? Filtering it, that's the process. And then how do I get another r squared? I put another part in there, right? So I'm going to get positive 25. And the person who gave positive 25 when I multiply and give a negative 10 by subtracting another 5 right here. Now, if you multiply this across again, you will get an r squared. Then you will get a minus 5r. And you get a negative r. And you will do this together. You add this two together, and you will get that. So that is the purpose. Now remember, this business right here, this equation is equal to zero. That's the whole purpose, right? To make it this a homogeneous part of it, right? Making this a homogeneous. In other words, we making we making y prime, y double prime minus 10y prime plus 25 equal plus 25y equals zero, right? That's all we do, right? So now, but we can forget about it because we're going to use that. Just keep that in mind. The right side we're not using yet, but we'll use it later, right? So let's do it. Okay, so now let's solve for this. Let's make this equal to zero. When I solve for that, r is equal to, right? So do it step by step. 5 equals 0, right? So r is equal to 5. Right, right here. R minus 5 equals 0. R is equal to 5. Notice that I have two roots that are the same, right? And when I have two roots that are the same, the complementary solution, is going to be y of c complementary is going to be the following. It's going to be C1 e to the fifth, right? E to the fifth x, right? Plus C2 plus C2. Now, and C2 I gotta be careful because I have two roots that are the same, right? Exactly, two roots that are the same. So therefore, I have to add another x, multiply the exponential e to the x, right? So this is my first step. So I found what is called complementary solution. Complementary solution. Now, let's do the most challenging part, right? That was the easy part, technically. Now let's do the most challenging part of the plan. Okay. So now let's do this. So let's do it. Right. So now you can see that I have this, right? Now, what can I do? Right? What I can do is make this y equal to something. This and this. Make this a chart. Take this and make it something over here, right? Pretending that it's equal to that. Now, technically, I have I have a, x to the 0 power, and I have nothing over here. So basically, I can say that y is equal to what? It's equal to a, right? The first constant that I have right here, ax plus b, right? Why? Because I have a 3. Exponentially, and then this is e to the 0 power. So b to the 0 power, so it's equal to 1, which is equal to that 3 right there. Now, having this, now I have to take the derivative, right? Because I have a derivative, right? I need to take the derivative, right? So now what? So it's going to be equal to a, right? Given that this is a 0, right? So so given that this is a 0, I just have basically um just let it, right? So now, because this is a constant, right? Now let's do y prime. Now y double prime is now because this is a constant. Now, having that, what I can do is plug in my values, and I say that Whenever I see a y prime, y double prime, I will put it whatever value it is, right? In this case, it's 0. So it's 0 plus what? Plus a, plus a, and then I do what? I do plus 25 times what? Times 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 a plus times ax plus b is equal to 30x plus 3. Okay, now notice that I have this. This will work out pretty nice, right? Now, but I have some issue that I need to kind of fix myself right here. So right here, I just realized that I should have 0 and I should have a minus 10 times a, right? Lost that. Now, what- this is negative 10. Mhm. This is negative 10a. And then when I multiply that, it's going to be equal to plus 25a x, right? And then 25ax, right? And then plus 25b plus 25b is equal to 30x plus 3. Right. Now notice that I have something back here, kind of similar, right? Before. Again, comparing apples to apples, right? In the equation, I have an x. I have this. Now, I need to make this equal to that, right? So I do 25a x equal to 30x, right? Divide by 20x on both sides, I get 25a is equal to 30, right? Divided by 25, right? And a give it 6 over 5. That is the value of a, right? B, right? So notice that I have this guy over here, and I got that guy hanging over there. This is constant. This is a constant, which this is a constant. So technically what I can do is the following. So I can actually, this is already being taken care of. It's gone, right? All I need is this, and so now what I do, I do right here. I will do it right here. So, right back, you know what? Let me do it right here. So let me have this, let me do this. So 10a, right? Plus, plus 10a plus 25b equal to 3, right? Now, how can I do this? Hey, how am I iterating, right? And I have a 10 minus 10 8 over here. So what can I do? Replace a, right? Huh? So I can say minus 10 is 6 over 5 plus 25b is equal to 3. Right. No, cancels out. It cancels out, right? This cancels by 2. This cancels by 1. So I have 2 right here, right? And I multiply this time with this and take that negative into account. I get minus 12 plus 25 is equal to what? Is equal to 3. Now, as you can see that divide b equal 3, right? Now, again, again, and then 12 here, and then 12 here, right? When I add 12 on both sides of this equation, I got 25. I got 25 b equal to 15, right? It's going to be equal to 15. Okay. Now, what is the next step? The next step right here is what? It's simply divided by 25, right? And divide by 25 on both sides, and I get what? I get b is equal to 3/5. Okay. Notice that I have now two values, right? One of them was a constant. Okay. So that's what that really helped me to solve the differential equation, right? I got this and I got that. So that is going to be that is going to be nothing but my particular solution. So y the p is going to be equal to, it's going to be equal to my a, but remember we found a, we had an x. So I need to have an x in front of that a. So it's going to be what? It's going to be 6/5, 6/5 x plus what? Plus 3/5. Okay? So now what I, in that is I add those two guys. I add this and I add that and I get my solution. All right? So and that is my solution for that differential equation. So yeah. So exactly what I have. So my solution is the following. So right, general solution is going to be, my 1a of c, which is my complementary solution, right? Plus my particular solution, which is going to be c1 e to the 5x plus c2 x, right? E to the 5x, and then plus 6 plus 6 fifth x, right? Plus 3 3/5, right? And that is my solution for that differential equation. Okay, so that's the first one. Let's do the second one real quick. So the second one, I am going to kind of speed up the process because I think you guys get it. If you get it this, you're doing good, and I don't have to. So the other one is the kind of, it's a little more difficult, but if I do it, um, without explaining too much, because technically it's a lot of algebra. Here's just a lot of algebra. We need to keep tracking a lot of steps, a lot of things going on. But that's more the most difficult part of it. Okay, so the next one is the following. The next one is 1/4, 1/4, right? So 1/4 y double prime, y double prime, right? Plus plus y prime plus y prime plus y equal what? Equal x squared minus 2x. It's not homogeneous, right? We agree with that. It's going to have a fraction over here. This the stuff that we need to be careful. We need to get rid of this. We need to get the y by itself. We want to make it that 2, in this case, is equal to 1, right? In this case, it's not equal to 1, so we have to get rid of that 1/4. So how do I get rid of that 1/4, right? I need to multiply that guy by 1/4 times 1/4 on the top, y prime, right? And then, actually, I can do it like this, right? I can just do it like this, right? And double prime plus y prime plus y equal what? I have to multiply everything, right? So I'm multiplying that, and then over here I multiply x squared minus 2x times 4. Notice that, notice that when we multiply, we get rid of this guy. Come on. But I'm not going to remember, I multiply that guy, and then I take this guy, multiply this one, right? So I got y prime, y dot prime, right? Plus, plus this guy times this guy is going to be equal to what? It's going to be equal to 4y prime. And then this times this is going to be 4y equal to this times this is going to be equal to 4x squared. This times this is going to be equal to minus ax. Okay. Now, notice that we got rid of that fraction and we have the y prime by itself. That's the step that we want. Once we put this in the form, we need again to find the roots, right? So now we find that r squared here, r squared plus 4r plus 4r plus 4 equal uh, okay, plus 4 is equal to 0. Hopefully I did this right. If I wrote the problem correctly too, because you got to be careful with that. Yes. Okay, so let's go. Now, what can we do here, right? So what we can do is the following, right? We can say that what add up to 4 and multiply what two numbers add up to 4 and multiply right here that multiply to 4. What add up to add up to multiply as to get 4r and multiply to get a constant that is a 4. Well, let's try r in the first place. Then plus what? Plus 2 times r plus 2. Let's see. R is r squared. R times 2 is 2r. And then times r is 2r. Right? Plus, wait, so r squared plus 2r plus 2r plus this times this is 4. Okay? So therefore, when I do that, add those 2 is equal to my 2r's in the middle, and then that's the right factoring. So now, again, Differential equation going back to high school algebra, right? That's what they saw paying attention in high school. Now, okay, so now we know that the roots for the following, so r plus 2 times r plus 2, r is equal to negative 2, r is equal to negative 2, right? Again, we have similar roots, so therefore the yc is going to be equal to c1 e to the minus 2x, right? Plus c2e to the minus 2x, right? But remember, because we have repeated roots, I need to add an x over here, okay? And that is our y sub c. That is our complementary solution. Okay, so let's work this out. Let's work this out. Now, because I need some room over here, I need to rewrite this up here. I got y prime, y double prime plus 4y plus 4 plus 4y prime plus 4y is equal to 4x squared minus 8 minus 8x. Okay, now let's do this. Now I know the roots, right? I know the root. Now my next step, and I know my complementary solution. Next step to make this guy somehow equal to that with the power of reducing powers, right? So now let's set up a y, right? So y equal to what? Equal to a x squared, right? Because they have this the highest power plus. And this is another thing. Just because I have a minus over here doesn't mean that when I do this over here, I have to have a minus. No, you use a plus sign. You use a plus sign. Everything will work it out by itself afterwards. So now, so I have this, right? So I should have a bx, right? And because I have a bx, I should have a 1 less power plus c, right? Second power, 1 power, 0 power. Right? Now let's do the derivative. What's the derivative of this? What's the y prime of this, right? I bring this in front and I get what? I get 2ax, right? And then what is the derivative of this? The derivative of this is plus b, and that's it, right? The derivative is 0, so I don't worry about it. Now let's do the derivative, second derivative of this one. So y double prime of this is going to be, take the derivative of that guy is going to with respect to x. I get 2a. Take the derivative with respect to x is nothing over here is constant, so it's 0, right? So that is the second derivative, okay? And that is the first derivative. Okay, so now I have the second derivative and the first derivative. And what I can do is put this into my equation, right? And that will give me something. So that will give me what? Will give me the following. So that will give me the following. So that will give me this. So it's going to be 2a, right? The second one, 2a, and then the first derivative is going to be plus 4 times what? Plus 4 times 2a plus 2ax 2ax plus b, right? And then plus 4 times what? Times everything that I have right here, right? Times everything that I have right there, which is 2x squared plus bx plus c, right? And that is equal to what? My right hand side, which is, we modify it, we got this one. We got a 4 in front of it. And we got what? We got 4x squared minus 8x. Right? Now, over here, just to make it sure, you can 200 extra front over here, you can add a plus 0x. Okay, now, let's work this out. So I keep my a right there, my 2a. This time this is going to be a x, right? Plus 4b, right? Right? And then plus, this time this is going to be 4ax squared. This time this is going to be 4b, to be 4bx, right? And then this time this is going to be 4c, right? 4c equal to 4x squared minus 8x plus 0x. Okay, so I told you it's going to be kind of hairy, right? But it's worth it to do this work because it's going to be working out. So the bottom line is, like I said, all you have to do really is keep the track what you're doing. Slow down. Don't start just trying to move things around. Be consistent in your work, and you will be okay in these problems. So now, what do we do? Right? So now, let's take care of the big guy first, the big exponential. Notice that I have over here ax, I have 4ax squared, and I got this guy. Right? So what I can do here is the following. So 4ax squared is equal to 4x squared. Right? Now, notice that this cancels out, that cancels out, and I get 4a equal to what? Equal to 4 divided by 4 divided by 4. Now I get my a is equal to 1. I knocked it out the first value already. That's done, right? Now, this is, okay, so we can say that this guy is gone, and it's gone, right? So let's do the next, right? We have three. So over here, what do we have here? I got ax, and also I have a 4bx. Okay, okay, okay. So we have this guy. I got this guy. Right. So let's put those together. Right. So I got ax plus this and this. That's what I'm doing right now. Plus 4bx equal to negative ax. Now, to clean this up, you can divide by x, right? X is common. So divide by x. Divide by x. The whole thing right here. And we get what? We get 8a plus 4b equal to minus 8. Right? Now that I have here for this already, so I can actually try it in right here, right? To find my b. Okay, let's do it over here. Matter of fact, let me, yeah, I don't need this already. So, I mean, okay, so let me do it right here. Let me do it right here. Let me do it. Let me do 8a plus 4b is equal to minus 8. Okay, I got 4. I get 8 times 1 plus 4b is equal to 8. Now notice that I can actually have 8 plus 4b minus 8 minus 8 minus 8 on both sides. We don't discriminate in mathematics. The only time when we discriminate is when we find a discriminant. That's it. So, okay. So we don't discriminate, right? We subtracted 8 on both sides, right? And then after we subtract 8 on both sides, I get 4b is equal to minus 16, right? And divided by 4, and I get a b is equal to negative 4. Right? Getting there. We got it there. We have my value of A, I got my value of B. Okay, so we get some progress. Now, what else do we have? So this is done. This is done, and this is done. I still have some values over here. I got a 2a, 2b, I got a 4c, and I got a 0x. I need to play with, right? So, we find what those values. Okay. So what do? I do what? I do 2a plus 4b, right? This one plus 4c equals 0, right? Okay, so what do I verify the value of, well, I erase my a. A was equal to 1. A is equal to 1. I got the value. I got some variables over here that can be substituted by these values. I got my A, I got my B, right? So the 2 times 1, right? Plug in that into that. And then my B is negative 4, so it's plus, 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 plus 4 times negative 4 plus 4c is equal to 0. Now notice that I can actually do my beautiful things over here. So I got 2 plus minus 2 minus 16 plus 4c is equal to 0. So this equal to negative 14. So negative 14, right? Negative 14 plus 4c equals 0. Right? When I take this and move to the other side, well, I make confusion over here. So okay, so actually, you know what? Let me just do it right here, so it's clear. Actually, let me do it right here. Let me just write the whole thing out. So it's negative. So right here, right? So it's negative 14 plus 4c equals 0, right? Now, what do I do? Right? So I get plus 14 plus 14, right? And I got a 4c is equal to 14 divided by 4 divided by 4, right? And 4c is going to be equal to 7 over 2. Okay, So what is going to be my solution? That's the question, right? So my solution is going to be the following. My solution is going to be the following. So it's going to be this plus this plus this and plus that. So it's going to be y general is going to be c1 e to the 2x plus c2 x e to the 2x, right? Plus 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 a, but what was a initially? Was square, right? So that's going to be equal to is going to be equal to x squared, right? Because 1 multiplying that x squared is going to be equal to x squared plus, and then it's going to be minus. What is the minus, right? So minus, what is the next value? It's going to be, technically it's supposed to be plus, but in this case it's minus because that's the value for b, right? So now it's going to be negative 4x, right? And then lastly but not least, it's going to be, last but not least, going to be the value of c, right? Which is a constant. You got this, you got exponent, one less exponent, right? Which is this 2, 2, 1, 0. Okay? So now it's going to be equal to what? Simply that. It's going to be 7 half. And that is the solution for that differential equation. I hope you learned something. And if you did, give me a like. And remember, we learn something every day because Jesus is good. Thank you for watching. See you in the next video. Thank you for watching.